Okay, so taking up from where we left off, what we'd like to do now is just open up a new project where we have the payload model, where we basically have all the architecture and fidelity levels pre-made. So there's the FLIR low to FLIR mid fidelity action, and then there's a FLIR mid to FLIR high, and then that transitions into a synthetic aperture radar architecture. So FLIR high to SAR low, that's the low fidelity version of the synthetic aperture radar, and then it just keeps going like that. So this transitions to a mid-level model and then a high fidelity model, and then from there we transition to the combination model, the low fidelity version, then the mid, and then the high version. So we have 3 different architectures and 3 different fidelity levels per architecture. So very easy, of course, now to perform these transitions with the fidelity actions or with the named history. We can also just open up, just load a level that we're interested in. So let's say we want to open the, the SAR low model. We can load that level. Okay, so this is the fidelity level 1 of the synthetic aperture radar, and it's basically the same kind of model you saw before with the infrared camera, except now we're using a synthetic aperture radar. So one thing we can do is, we have to decide, basically, we've made all these models, we have these different fidelity levels, and our objective here is to kind of pick the one that we really want to use. So one way to do that is to compare the lower fidelity models. So let's confine our attention right now to just the synthetic aperture radar, and then we'll look at the overall system comparison, the comparison that is between architecture and fidelity levels. But for right now, let's try to compare the low, mid, and high fidelity versions of the synthetic aperture radar. So to do that, we can do a run compare. So we can hit this compare button. Okay. What it's going to ask us for here, this is a little bit wordy, but what it says is, tell us the time you want to compare for, and then say what list of subsystems that you want to compare and the variables that you want to compare are. So in order to do that, I'm just going to sort of cheat, and I'm going to copy and paste. Basically what we're comparing here is the synthetic aperture radar, the one right here that exists on our screen right now, with the mid-level subsystem as it exists in the library, this one right here, and the high level one also in the library. And the variables that we want to compare are the signal to noise ratio. We're going to say OK to that, and what it's going to do is it's going to start running in the background. So that's what it's doing now, is it's loading up ScriptSim, doing its simulation run for those 3 subsystems. Okay, and so when it's finished, which it is right now, what you get is a little table. It's just brought up as a text file to make it easy to read. So what we get is a time in seconds for each of these 3 subsystems that it took to run, and then a time as a percentage of the best one. So you can see here that the high fidelity one took a lot more time to run. It still wasn't very much time, but it's quite a bit more compared to the mid and the low fidelity model, which are just curve fits. So this mid fidelity model, the low fidelity model ran in 3.5% of the time, as the highest fidelity model, and the mid fidelity model ran in 3.9% of the time. And then over here we see the signal to noise ratio as a percentage of the best results, which we presume to be the high fidelity model. So we'll call that 1. The mid fidelity model was 97% of that, and the low fidelity model was 79% of that. So you can kind of take a look at this and you can say, well, I got, in 3.9% of the time, I got 97% of the result. Maybe I should be using the mid-level model for doing my trade study analysis and stuff like that. There's a couple other things that are shown here that I haven't really emphasized yet. One of them is this complexity number, so this gives you an idea of how complex each model is. And there's also some introspection of the model going on here, so it tells you how many connections each model has, how many number of outputs, number of parameters, and then there's a complexity number, which is derived from that, length of the calculation that's derived from that. So that's what the complexity is. And then the subsystem ID is just the name of the model, dot the number of connections, dot the number of outputs, dot the number of parameters, dot the length of the calculation. So this is just a way of classifying the models using numbers that mean something. So, okay, so that's what compare does. Now, once we've done the compare, it stays in memory, and we can use it to ask what the benefit is of any particular level. So if I ask, if I say, well, I want to understand how good the SAR mid model is, I have to say true here because it's in the library. I can hit the enter button there, and what it'll do is it'll tell me, well, if you want to use the SAR mid model, be aware that it's 97% as accurate as the highest fidelity one that you ran. It runs in 3.9% of the time, just the same as what we saw. And also the table that I just showed you is also displayed here. So if I want to run low fidelity, if I wanted to run the highest one or the lowest one, I could just ask what the benefit is of any subsystem I was interested in, and I would get the information here. Okay, so there's a similar concept for comparing entire architectures and fidelity levels. So if I wanted to compare this architecture and fidelity level with this one, what I did there was just compare the subsystems themselves. So it's just the subsystem calculation, which calculated the signal-to-noise ratio. What I'd like to do now is compare the entire system, one architecture versus the other. So it's kind of the same, but it's a little different because we're running the entire simulation now, and we're comparing the time for the entire simulation. So this is similar. I'm going to hit the compare sys button, which asks for architecture and fidelity levels, which are themselves system models. That's why it's called compare sys. And it also follows a same format. I have to say what time of the simulation I'm interested in, and then I have to list out the systems and the variables that I'm interested in. So once again, I'm going to cheat. I'm just going to highlight it over here, and I'm going to go in here and paste it in. And what we're interested in here is the accuracy, the cost, the weight, and the total power. And we're going to hit the go button, and it's going to run those three systems in the background and show us the result, kind of the same as what it did before. This takes a little longer to run because it's running the entire simulation. Okay, and there it's finished. Okay, so what you get is another table, and in this case we get more output because we asked for more output. We get this is the cost, weight, power, and accuracy. So again, what we're seeing is the SAR mid model gives us results that are in the high 90s in terms of a percentage of the highest fidelity model. Meanwhile, the time that it takes to run the model is quite a bit smaller. So in 70% of the time, you get in the high 90s in terms of how good the result is. If you use the low fidelity model, the accuracy isn't so good. The results aren't so good, although you spend less time doing them. Now, I might add that the delta times here as percentages are not quite as dramatic as they were for just the subsystem, and that's because we're running the entire system model. And some of the benefits of using the lower fidelity models are washed out because there's a lot of overhead in computing the entire system. It has to load up scriptsim, it has to run the calculations, and communicate back and forth with the Python code. And it's a somewhat inefficient process, and that's why you're not getting the dramatic results that we got for just the subsystem, which only calculates the subsystem calculation, the engineering calculation itself. Okay, so just like we did before, we can also ask for the benefit of a particular system. So it'll ask me, well, what architecture fidelity level would you be interested in? You can say SAR mid, for example, and it'll tell you, here's the percentages of the results of the best model, and here is the percent of time that it takes to run that model. So you can make the decision, in this case it might be a rational decision to say, well, I'd really rather use the mid-level fidelity of the SAR architecture. So that's how that works. There's also a wizard. I'll show you that in another video just because time is getting short.